This is a huge moment. You're about to learn how to solve differential equations using separation of variables. These are also known as separable differential equations. If you're taking A, B, or BC calculus, you're going to have this as a decent part of your curriculum. It's going to be on the exam. With that said, if you're in a Calc 1 or Calc 2 class or other calculus class, it might not be in your class. It's still wicked rad. So we're going to learn how to solve differential equations that allow us to separate variables. So essentially what this means is you want to get all of the x values together and all the y values together through multiplication or division. Essentially, you want to maintain area. Like you can't add or subtract both sides of an equation because we want to end up with a dx or a dy. Now, there's more to it than that in pure math, but that's the idea that I like to put out there first. So I'll show you the y at the end of the video. This says find the particular solution y equals f of x. So that means we're finding the solution to the differential equation now with the given initial condition, 0, 3. So we're going to end up solving for c. So how do we do this? To separate variables, and you always must show this first step. So important. If you don't, you lose all points on a problem. What I do is I get the y's together. So I'm going to divide both sides by y and multiply, technically not, but I'm going to multiply both sides by dx. That gives me dy over y is equal to x squared times dx. Multiplied both sides by dx divided by y. That got the y's together and the x's together. That was the purpose. Now that the variables have been separated, we're going to integrate both sides. Okay, so if I'm going to integrate both sides, we do that like normal. The rest of these steps are pretty simple. This means you eventually want to solve for y as a function of x. So you want to get y alone. So what I'm going to do now is integrate this. 1 over y is the natural log of the absolute value of y. It's normal integration. And the integral of x squared is x cubed all over 3. Don't forget about the constant of integration plus c. Now we don't have a constant of integration on this side because we're going to have a constant on that side. And if I added a constant and then subtracted it from both sides, a constant minus a constant is a constant. So that's why I don't have a plus c on the left-hand side. Now my goal is to solve for y. At this point, some teachers will tell you solve for c. Plug in 0 for x and 3 for y and solve for c. And you can do that. I don't do it that way. I solve for y and then I solve for c at the very end. It does not matter the order you do it in. So I'm going to get y alone. To do that, I undo ln. This is a lot of algebra from here. I exponentiate both sides. That undoes the ln, and that gives me the absolute value of y is equal to e to the, now this is all one exponent now. So you now have x cubed over 3 plus c, and it's all an exponent. Why is that important? You'll see in a second. Anytime you have an exponent, that's being added to another exponent, the bases are being multiplied, right? We could multiply them, and we could add up c and x cubed over 3. So why is that important? Well, what's e to a constant? It's a constant, right? It's some constant. So a lot of teachers will just call that c, so I'm going to do that as well. And you might be like, wait, what? That can just become c? It's a constant. And if you think about it, if you plug in for your initial condition, you're going to eventually need to take the ln to get that c alone. And then when you take e to the ln, you're going to undo each other. So e to the c is just some constant. So we have the absolute value of y. Now, how do we undo the absolute value of y? Well, let's think about this. Let's say I had the absolute value of y equaled 4. Y would then be equal to plus or minus 4. It'd be equal to either of those values, right? Either positive 4 or a negative 4, either one. So, same thing goes here. Y would then be equal to technically plus or minus a constant. Well, hold on a second. Whether you have plus a constant or minus a constant, it's still a constant. So you have c. And there you have that constant swallowing up any operation that's done to it. So any direct operation that's done right to the constant gets swallowed up, if you will, by that constant, right? Because plus or minus a constant is still a constant. Now, at this point, you've solved for what is known as the general solution. That's what that is, of a differential equation. How do we solve for c? We use that initial condition. So I'm going to take this and we'll go over here. And that just means plug in for y and plug in for x. So 3 equals c e to the 0 cubed over 3. Well, e to the 0 cubed over 3 is e to the 0 or 1. So c equals 3. And of course, we're going to evaluate c back into the function. So that's 3 e to the x cubed over 3. And you now know how to check your answers. We did that in lesson 1. You could take this, right, and plug it in here and see if you end up with the derivative. So you take the derivative of it, you set that equal to x squared times this, and true to form, it's the right answer. Isn't that wicked cool? So that's separation of variables. I'm going to leave it at that for this video, and then in the next video, I'll go over another one, and then the next video, another one, and so on and so forth. So that's a separation of variables problem. We'll do a few more for you just so you get it down well. Can't wait to see you in the next one. Peace.